So you were discussing the binary logistic regression, right? So machine learning, supervised learning, classification algorithms, when the dependent variable is non-numeric, either binary or multinomial. Multinomial means more than two. So binary logistic regression explains the linear relationship between a binary dependent variable y and multiple independent variables. And the equation is this. So probability. In binary, in classification, we get probability. In regression, we will get predicted values. Whereas in classification, we will get probability, predicted probability. Here, you can see here, probability is equal to exponential to the power of intercept plus b1 x1, b2 x2 till bn xn divided by 1 plus e to the power of intercept plus b1 x1, b2 x2 till bn xn. Probability is equal to 1 by 1 plus e to the power of minus z. Short form is this one. 1 by 1 plus e to the power of minus z. Z is the regression equation. Then the various components are this. P is the probability, E is the exponential, B0 is intercept, B1, B2, B3 are coefficients, X1, X2, X3 are your independent variables. Okay. So when you look at the classification, we need to understand the binary logistic regression looks similar to linear regression only. Only thing is, it's a classification, the dependent variable structure will be, and the classification rule for all binary algorithms is this. Probability greater than equal to 0.50 will be classified as 1. Probability less than 0.50 will be classified as 1 is always yes, 0 is always no. Okay. So the classification rule based on the probability is greater than equal to 0.50. So we also discussed some basic assumptions. Logical linear relationship must be there. No multicollinearity. Sample size required is minimum 50 observations per. For all classification, minimum 50 observations. For regression, 20 observations per variable. For classification, 50 observations per variable. Regression, 20 observations per variable. This is your thumb rule, roughly speaking. But there is sampling theory. Once you go to industry, you will also refer to the sampling theory is there. There is a different formulas or methods are there where you will find out the optimal sampling based on statistics. Okay, that we will discuss later. Advanced statistics is there for sampling. The size which you require for large scale data will be decided based on the sampling theory. And the interpretation of output in Python is based on confusion matrix. The confusion matrix is very important for all classification problems. The confusion matrix will be created in the backend. What is the confusion matrix? It's a 2 by 2 cross tabulation of actual class and predicted class. So it's a 2 by 2 matrix for binary. Binary it is 2 by 2. Multinomial n by n. For multinomial it will be n by n. For binary it will be 2 by 2 matrix of actual class and the predicted class. So actual positive, predicted positive, true positive. Actual positive, predicted negative is false negative. Actual negative, predicted positive is false positive. Actual negative and predicted negative is true negative. The 4 quadrants of your confusion matrix. And false negative, we call it as type 2 error. This we call it as type 1 error. So type 2 error is more dangerous. Type 2 error means patient has COVID. Patient has COVID. But RT-PCR test said no COVID. What will patient do? He will not take any medicines. COVID will become even worse and he might die. That is type 2 error. Type 1 error is patient does not have COVID. What will patient do? He will have some side effects. But in the other case, type 2 error, he can die because he didn't take proper treatment. So type 2 error is very, very dangerous. Type 2 error is very, very dangerous. So in classification problems, we always look first at type 2 error. What is our type 2 error? How much it is giving? Take for example, your algorithm is not predicting the type of employees who are getting promoted. It is predicting who are not getting promoted. But who are getting promoted is not predicted correctly, which is a problem for the predicting non-promotion guys is okay. But who are getting promoted? Those predictions are wrong means your model has a bigger problem. So to overcome this, type 2 error is a very, very dangerous situation. So common interview questions will be which is more dangerous, type 2 error or type 1 error. Type 2 is more dangerous. Type 2 is more dangerous. So patient has COVID, but RT-PCR gave negative. Negative means no COVID. Patient doesn't have COVID, RT-PCR tested COVID positive. He will take some medications and he will have side effects, but he will not die, right? So that is the problem with type 2 and type 1 error. So type 2 error is more dangerous. Type 2 error is what we have to constantly monitor in our classification problems. In our classification problems, we should focus on type 2 error. First thing you should observe is what is my type 2 error. The interpretation in Python output is the dot score function in regression will give us R square. Dot score function in regression will give us R square. Whereas here it will give us accuracy. Now accuracy is calculated from confusion matrix, which is calculated from confusion. So by default, a confusion matrix will be created in the backend. Then only it can calculate accuracy. Without confusion matrix, will you be able to calculate accuracy? So confusion matrix is compulsory. So these are the various metrics which are calculated from. The most important is true positive plus true negative divided by all four. True positive plus false negative plus false positive plus true negative. So all four, this is the core metric. First, you should always look for accuracy. Then other metrics. Other metrics means these: sensitivity, specificity, precision. One more metric is there, F1 score. That is also nowadays very, F1 score is also one of the important metrics. So your F1 score is also important. F1 score is calculated using the precision and recall. Precision and recall. 2 into precision into recall divided by precision plus recall. Or 2 TP by 2 TP plus FP plus. So you can use precision and recall directly, which is calculated. Recall is nothing but the other name of sensitivity is recall. The other name of sensitivity is recall. True positive by true positive plus false negative. Precision is true positive by TP plus FP. Okay. So this you have to remember. You will get compulsory questions on these metrics. Formulas, you have to mug up and remember these formulas. And one of the important metric is F1 score. F1 score is also very important. Nowadays, a lot of people are asking for F1 score as a primary metric along with accuracy. Along with accuracy, F1 score is also very important. So this is the formula for F1 score. So these metrics are very important in classification. So in classification data, you have more metrics compared to regression. In regression, what we have only residuals. From residuals, we calculate RMSE. Whereas in classification, from confusion matrix, we have to calculate sensitivity or recall, specificity, precision, true negative rate or negative predicted values, F1 score, all these things are calculated. So metrics are high in classification algorithm. Regression, we will take RMSE, root mean square error or mean square error. Without square root also, you will take mean square error. Okay, so these are the metrics which are very important in classification algorithms. One other metric which is important is area under the curve. Area under the curve or AUC curve is also one of the important metric in. So area under the curve or what we call it as, so receivers operating curve. So binary classification, AUC curve is also very important. Area under the receivers operating curve or ROC curve is very important. So as you can see here, the threshold is 0.5. Okay. If you get this blue type of curve, it is perfect. So anything between this blue and orange line is okay. Okay. Anything between this blue and orange line is okay. So this orange line will be somewhere around 0.5, right? So above closer to 1 is what we require. ROC curve will when we plot, and what is used to plot it? False positive rate and true positive rate. So if you look at the x-axis, false positive rate. If you look at the y-axis, it is true positive rate, TPR and FPR. Now, TPR and FPR are the important part of your metrics. So true positive rate is nothing but, and what is false positive rate? False positive rate is false positive by false positive plus true negative. Opposite to TPR. In TPR, what we take TP by TP plus FN. TP by TP plus FN. In false positive rate, FP by FP plus TN. FP by FP plus, so this is your false positive rate. So using this true positive rate and false positive rate, it will plot the ROC curve. So how accurately your model is predicting is what ROC curve will tell us. See, all these metrics will tell us how accurately your model is performing, how accurately it is performing. Because see, these are very important decisions. Loan approval, yes or no. It's a very risky decision, right? And why we are using software? Because humans doesn't want to take that risk. If you ask a bank manager to approve a loan, he will not do it easily. So that is what banks used to have problem. You will not get loans easily in State Bank of India, all these public sector banks, right? But you will get loans very easily in private banks, ICICI, HDFC, and all these places. Why? Because ICICI, HDFC started as, from day one, these banks were software banks, whereas SBI were people banks. You have big branches, 30, 40, 50 people work in those branches. A branch manager will be there, assistant branch manager will be there, a lot of people will be there to take a decision. Whereas in ICICI, HDFC is nothing. If the software says yes, loan will be approved. If the software says no, loan will not be. So when you are looking at all these metrics on how these decisions are made, or accuracy will be used, ROC curve will be used, various other metrics also will be. Based on these metrics, the approval will be. That is why you see banks, private banks are very fast in giving because they use these models. These ML models are used by these private banks to approve loans. In fact, they have very advanced implemented. HDFC has implemented the first one, Insta loans and Insta loans. Simply net banking, to simply say yes, you will get money in 10 seconds. No verification, no documents, no signing of loan agreement, nothing. No references, nothing. Purely based on your banking profile. Purely based on data. These loans are approved. And the failure rate is very, very less. Because algorithms take a lot of dimensions. A human being can take 3 dimensions. Whereas an algorithm can evaluate hundreds of, it can look at combination of different variables and find out which is the best. And based on that, it will decide whether to approve the loan or not. So that is where this all metrics come into picture. Most of the business problems are classification problems. Most of the business problems are classification problem. Patient has cancer or not, based on the MRI, magnetic resonance imaging, which is very advanced. Big sheets will get lot of images, minute images will get. There also doctors don't need to do anything. The computer will tell you where the problem is. How it will identify based on the software, based on the algorithms, it has inbuilt into those systems. It evaluates these images and runs image processing algorithms. Every time an MRI is taken, it will be added to the centralized database. There is a centralized database. For GE, it is in US. For Philips, it is in Switzerland. They have the centralized database. Anywhere in the world, if it is a GE machine or a Philips machine or a Tesla machine, once the MRI is taken, automatically those images will be stored in the central server. And those images are constantly updated, and the algorithm also will update itself. That is why they have very, very high accuracies. Ultrasounds also. Because they need data, right? To fine-tune the algorithm. We constantly need data to fine-tune the algorithm. So where does this data comes? From our actual medical scans, which go into the centralized database, and the algorithms keep on improving the performance on the new data which is coming into the. So COVID time, the chest X-rays were new, right? COVID was new. So COVID was being classified as pneumonia. There is a marginal difference between COVID and pneumonia. You know pneumonia, right? Lungs will have all the phlegm and water will get, and people will die with, they can't breathe and all. COVID also was doing the same thing. So what is happening? X-ray machines are showing it as pneumonia, whereas the actual is images are similar. We will work on those images when we do deep learning and image processing. They look very similar. So, but X-ray machines were not programmed for finding COVID, right? Which is a new disease. So this constant data has to be updated. Within 15 days, the new COVID X-rays are uploaded into the machines, and all the X-ray guys were told to update their softwares. The X-ray machines were constantly finding out COVID with 50% accuracy. Initially, it was 50% accuracy. Now it is around 80% accuracy. From the chest X-ray, it will tell you whether COVID is there or, because what is happening is COVID will go to some specific parts of lungs, whereas pneumonia is whole lungs, complete lungs. COVID is attacking some specific parts of the, so initial stages you can easily identify. So there's a lot of things which algorithms have to do. Because initial stage of COVID, we call it as lung infection. Lung infection is common. People who have small lung infection, you will get cough and phlegm. That is common, not life-threatening. But COVID, if it is not identified at the beginning point, it will become life-threatening. So we call them markers. You need to find the markers in the X-ray, which will highlight the. So that is where algorithms will come into. For your naked eye, you can't see the difference. For us, we don't see the difference. But algorithm can do it, because algorithm will convert the images into pixels. Pixels are nothing but numbers. Minute number changes will be identified by the algorithm. and then it will find the disease. So all these things can be done by algorithms. So most of it is binary decision, whether a tumor is cancer or whether ultrasound of baby scans, baby is fine or pregnancy scans will be there, right? So there you have to look at the image as well as the heartbeat of the AV data. We call it as AV data. Heartbeat of the baby also has to be monitored, and the image of the baby in the womb also has to be monitored. Based on these two set of data points, we will say, the doctor will say baby is healthy or right. So all these things are binary decisions, yes or no. Everywhere it is yes or no, binary decisions. That is why one of the important metric is ROC curve. See, it is all about confirming again and again the decision is correct, because sometimes machines might go wrong. Why they go wrong? Because if the historical data is not good, obviously machine will predict it. It all depends on historical data, right? Whatever data you give to machine, based on that, it will predict. If your historical data is wrong, your machine also will predict it. So the data is very important. The data which is going into the algorithm is very, very important. A lot of care has to be taken to make sure the data is validated and reliable. Data validity and reliability are two important things which you need to always, okay? So here, true positive rate, TP divided by false positive, FP divided by FP plus the two metrics which are very important for plotting the ROC. So we already have cleaned the data in HR analytics. We have already what you call dummy encoded. Everything has been done, right? Combined DF underscore clean is what we have already done. Yeah. Yes, please. No. There, see, there you get a predicted value. Here you get a predicted class, predicted probability, right? So there are two different things. So in regression, you get what? A numeric value you will get. In classification, what you get? A probability. And you convert the probability into 1 and 0. And confusion matrix is same, actual and predicted class, right? Actual is 0, 1, predicted also 0, 1 you will take, and you will do a confusion matrix. There it is value, minus. Here it is cross tabulation, because they are categorical. For numeric, you can calculate difference. For numeric data, you can calculate minus, plus, minus, division, multiplication, all you can do. For categorical data, what you can do? Two things only. You can count, 1, 2, 3, count can be done. You can do cross tabulation. Two variables you can do and do a cross tabulation. Only you can do these two things. Whereas on actual numbers, you can do a lot of things. You can calculate logarithmic values, exponential values, all mathematical things you can do them. But in case of non-numeric, and it is 0 and 1, what you can do? You can count how many zeros are there, how many ones are, or you can take actual and predicted classes. How many 0 zeros are there, how many 0 ones are there, how many 1 zeros are there, how many 1 1. That's all. You can do those cross tabulation calculations. So that is a regression. This is classic. Here also actual predicted will be there, but you have to do only cross tabulation. Now, one of the important thing is split data into X. What is X? Independent variables. Capital X is always independent variables, and small y. Small y is always dependent variables. There is only one single dependent. There will be multiple independent variables. Y is equal to combined DF underscore clean dot is promoted. Capital X is equal to combined DF clean dot drop is underscore promoted, comma, axis is equal to 1. Axis is equal to 1 is column dropping. Axis is equal to 0 is row dropping. Y is equal to combined DF underscore clean dot is underscore promoted as separate. You cannot have two variables in dependent and independent. It has to be only one, right? So that is why we are dropping it from independent variable. Once we separate it as dependent variable, you must drop it from independent variables. Otherwise, algorithm will say duplicate variables. Otherwise, algorithm will get confused. Duplication will be there, right? It is a dependent variable. Same variable is there also in independent variable. Algorithm will simply say duplicate variable found. To avoid this, once you separate y, you have to drop it from x. You have run all the cells. Open the notebook and run all the cells. Okay. Always remember, once you open the Jupyter notebook, you have to run all the cells. sklearn dot linear underscore model import logistic. sklearn dot linear underscore model import logistic regression. Give a short name to the model. Logic is equal to logistic regression. Logic model is equal to logic x comma y. Oh, unknown label type unknown. We have cleaned it, right? Combined DF clean. Oh, sorry. We did not label encode Y. We have not label encoded Y. That is the problem. We have to label encode. We have to label encode dependent variable. We have done get dummies, right? Get dummies is done here, right? And we didn't drop actually. We have dropped from HR test sklearn dot preprocessing Y is equal to label encoder dot fit underscore transform Y. Int and string is there still. Y is equal to Y dot as type. Oh, this also we got an error. I am using wrong data. No, we have already split the data. HR train DF dot is promoted, not combined DF clean. We have split the data, right? And that's what I'm getting doubt where I make it this. See, I have used combined DF. Let me check once. I'll confirm what mistake we are making. All right. So all of you go to the point where we have cleaned the data. Before hypothesis testing, we have done it, right? We have split it here. Instead of combined DF, you have to take it as combined DF underscore clean. When you're splitting the data, it has to be combined DF underscore clean, not combined DF. All right, corrected this. Scroll down and you can, so use HR train DF. You got a warning here. This is also very important warning. You should always look for. So what is the warning saying? What is the warning? It is saying the primary thing is convergence warning. All of you got warning, right? Convergence warning. Now, in machine learning, this is a very important thing which you need to understand. Convergence warning, all the coefficients, which is typically what coefficients are what? Coefficients are your betas. In the model, as the number of iterations were not convergence warning is thing. It will, you might get convergence warning in regression. You might also get convergence warning in classification. What it means is all the coefficients, betas are there, na? All the betas were not able to be calculated. Some variables betas were not calculated. Why they were not calculated? Because the number of iterations required for calculation were not. So what it is suggesting, the error in Python also suggests. So what it is suggesting? Two things it is suggesting. Increase the number of iterations or scale the data. Standard scalar, min-max scalar, we have all those scalars on numerical data, right? But the problem here is we don't have that many numeric variables. Here, most of the variables are, if there are many numeric variables, then scaling would work. Or the first strategy, increase the number of. So what we simply can do is, we can simply go here into the logic model, max underscore iter is equal to 1000. By default, iterations are 200. So I'm increasing them to a random value. Oh, still not sufficient. Then we'll make it 3000. See, now we didn't get the error. Now we did not get the error. So initially I did 1000 iterations, still were not sufficient. I randomly picked up 3000 iterations. So there is no fixed formula here. You just need to find it using trial and error. I'll tell you. Once you do the manual calculation, then you will understand. Similar to like that only. Do you know solver in Excel? Linear programming or derivative calculus, there is a concept called minimizing the error, reducing some weights. You have an equation, ax plus by plus c or some equation is there, where you have these a, b, c are coefficients or weights, right? You want to reduce the error. So when you have the equation, ax plus by plus c is equal to some error is there, right? Now, you want to find out what is the least possible error by changing the combination of A, B, and C. So what you will do? You will randomly start from some point and then you start minimizing it, right? Random choice, you will pick a number and then you will use your logical thinking. You will pick up a number and reduce the error. You try different combination of A, B, C, and you'll find the best possible combination where the error is. That process, we call it as solver model. So how will you do? It's an iterative model, right? So if you have more iterations to do, you can try more combinations. So there you will also get these permutations and combinations. You might have studied in high school mathematics, right? Permutation and combinations. NCR is equal to n factorial divided by n minus r factorial is there now. NCR combinations. So you can find lot of different combinations of, and then you will try to reduce the weight. But in real-time data science, you have a lot of variables. So the iterations are required to find the best possible. So by default is, this is not sufficient. You type in Google sklearn logistic regression, you will come to know what are the components you can give? Solvers to converge, maximum iterations for the solvers to. Now there are different solvers here. One of the important solver is, it might be less than that. Maximum you can use 3000, but before that only it is converging.
Only to find a relation between.
So this is the concept of linear programming, where we use this solver concept, where we solve an equation by changing different parameters. By changing weights or parameters, you try to minimize the error. In linear programming, you can have two things: maximization of profit, minimization of. So in linear programming, it can be a maximization problem or it can be a minimization problem. So minimization problem, simple thing we can do manually by doing a multiple iterations. But when you have large scale data, you have to use derivative calculus, where it will use random set of weights for each of these variables, and then it uses derivative calculus and various mathematical way of using different combination of weights and try to reduce that process. We call it as solving method or solver methods. Now there are different solvers in Python. If you can see here, LBFGS, liblinear, Newton, Cholesky, SAG, Saga. There are different methods of, all of them basically random selection of weights and using multiple iterations. Okay, so observations, that is a different thing. That is different. This is not, this is solving the error or reducing the error. Once we do the calculation, you will understand how the error functions work. You will understand once we do the manual calculation. All right, all of you got the iterations now. We don't get the error. Logic model dot score. Now what is this 93.16? This is accuracy from, yes. Now logic model dot predict. So we are predicting for all the independent variables, sorry, all the observations. Dot cross tab y comma, you will get the confusion matrix. So in this matrix, what are correct predictions? Is correct prediction, right? 0, 0, 1, 2, 2, 9, 1, 1. Rest of the all are wrong predictions. 49, 8, 33 plus 307 plus 3439 1229. You will not get same value. Marginal difference will be there. Why there is a marginal difference? Small difference will be there, not big. This algorithm has random state. Like we told in a solver, the first weight will be randomly taken. Since we did not fix the random state, we all get different, because my random weight will be different, your random weight will be different, his will be different. Because we can't control random numbers, right? You can't control random numbers. If you want to control them, you have to decide, give the random state. If all of us want the same values, let us say random underscore state 42, some random number you give. Now all of you give 42 as random state, you will also get the same output what I got. If we set the seed in the random, that means all of our random numbers will be same. If we set the random state as same value, all of us are giving random state as same value 42. So we will take same random weights. Then all of our answers will be correct to the decimal. Wherever there is a solver involved, solver is a random process. High school mathematics, we tried this, right? In high school mathematics, solving linear equations, quadratic equations. You remember? Solving linear equations, quadratic equations. How will you solve quadratic equations? Without formula. You randomly take the values, right? Or you can use the formula. Plus or minus b root of 2ac by b square by 4ac by 2a. So that formula you can use, or you can use random method, right? If you are good, you can use random method. You don't need to use formula. Now there will be different combinations of random methods. So when you have these different random methods, there will be difference. Now once you fix the random state, all of us get the same output, right? All of us will get the same output, closer to one another or same. Why? You are getting a different value still. See, this is the confusion matrix, right? And then it uses this confusion matrix to calculate accuracy. What is accuracy which I calculated here? Plus Tn divided by Tp plus Fp plus Fn plus from sklearn dot matrix classification report, comma, confusion matrix display, ROC curve display. From sklearn dot matrix import classification report, confusion matrix display, ROC curve display. From sklearn dot matrix import classification underscore report, comma, confusion matrix display. Type the first two letters and tab. sklearn dot matrix import classification report, confusion matrix display, ROC curve display. You're getting error? Yeah, I'll come. So confusion matrix dot display from predictions. You will get the same matrix what we got on the top. I think we can increase the fill size. Still, we are not getting this value. 49,833. Huh? Confusion matrix, all of you got this? 0.63 area under the curve. So not a good fit model, right? From this you can see it is not like that type of curve, no? What we got in the top. This is looking like this orange line. The curve looks like orange line, right? Good fit model. We didn't get that round shape is not there, no? Which indicates it's not a good fit model. AUC should be closer to 1, between 0.70 to 1, but it is less than 0.70. In the bracket you got now 0.63. In the image bracket, you can see the AUC curve. AUC value is 0.63. It should be between 0.70 to 0.95. All classification metrics must be in the range of 0.70 to 0.95. Accuracy, sensitivity, specificity, precision, F1 score, recall, everything. All the metrics must be in the range of 0.70 to 0. Under 0.70, under fitting, above 0.95, over fitting. Less than 0.70 is under fitting, greater than 0.95 is over fitting. So the range for all classification metrics is 0.70 to 0.95. And AUC also should be in that range only, but we got only 0.63, which indicates it's not a good fit model. Why it is not good fit model, we'll know from the classification. So in the classification report, you can see here precision, recall, and now the problem here is there are 50,140 zeros, 4,668 only ones. There are in our data 50,140 zeros, but only 4,668. We call this as imbalanced data. Dependent variable. Like in this case, zeros are 50,140, but ones are just 4,660. Now, the prediction of zeros is good. The prediction of zeros is, but look at the prediction of ones. Look at this recall and F1 score. They are very. Why the model is not working properly is because we have very few, less number of ones are there in our data. So the model is not able to predict the ones correctly. This problem, we call it as imbalanced data problem. So, or in the next, once we complete the models, we'll talk about imbalanced data, how to correct this problem by using oversampling. Oversampling means we'll make ones equivalent to zeros by using sampling methods. And then the model performance will automatically improve. So as of now, the imbalanced data is the problem why the model is failing in predictions. Because of this thing, see the recall is very, and F1 score is also very bad. For zeros it is overfitting, for ones it is, and overall it is affecting the overall accuracy is good. Overall accuracy is very good, 93%. But what about other metrics? They're all bad. AUC is bad. And look at the recall and F1. So when you have imbalanced data, we look for these metrics, precision, recall, and F1 score. Very important for imbalanced data, particularly for minority class. So generally we call this as this, we call it as minority. So this is how we do classification algorithms. The various metrics and confusion matrix you can manually plot. Rather than the picture, you can directly plot using the cross tabulation. Cross tabulation of actual is what? Y. Predicted is what? Logic predict. You have predicted, no? Okay. Actual class is Y. Predicted class is logic predict. Logic predict will give you class prediction. If you want probability prediction also, you can do that. Logic model dot predict underscore proba. So it is giving probability prediction for row number 1. Row number 1, it is giving the prediction. 82% is 0. 18%, probability is 0.82 is 0. 1 is 18. See, the first row is 0. Predicted is, why predicted is 0? Because the probability of 0 prediction is greater than the probability of, so the first one is 0 probability. What is the probability? The class is 0. This is the remaining, that class is 1. We have two classes, no? 0 and 1. We have two classes, 0 and 1. The probability of the first row is 0. See, the prediction is, so in probabilities you'll get 2. One is for 0, the other is for 1. Whichever is the highest, that is the class probability. Suppose, let us say you are looking at data frame. In 10, we don't see anything 1 predictions, right? All are zeros only. Any value for 1? No. let us say tail also all ones, zeros only, because we have very less ones now. That's why we are not seeing much of the one predictions here. We'll write it and then we'll check it. So initially you'll get probability. Based on probability, the class will be decided. Based on the probability, the class will be, because the equation will give us probability. The equation will give us probability. And based on the probability, you will decide whether it should be 0 or 1. Whichever is the highest probability, the class will be based on that. So we are trying to build a model to understand which type of employees are getting promoted. If you look at what is our business problem? So you can read, right? What is the problem the client is facing and prepare them in time. He wants it is for identifying the right people for promotion, right? Currently, they are following a process where they first identify the employees, then they put them in training, then they will use the KPIs and all these things, right? This is the process they are following. See here, training and evaluation period. So nominated for promotion and then promotion announcement. This is the process they are following. Now they want you to build a model, and what is the metric they are using, right? So they are saying, we want you to build a model that predicts which type of employees are getting. Okay. So our idea is to build a model, and if you give some data to that model, it will tell us whether the particular employee will be promoted or. So if you input the data into that model, it should tell you whether the employee will be promoted or, right? So this is used constantly in the companies to find what type of employees are getting promoted or not. So based on that, we built a logistic regression model. But the problem is what we want to find out this, right? This is our area of interest. 1 and 1 is the area of interest, but that is being wrong. A lot of them are missed. Look at the false negatives. See, typed errors are very. So actually, the employee was promoted, but your model is predicting it as not promoted. These are predictions, right? These are the predictions. These are the actual 0 and 1. So in this matrix, this is true negative. 0 is true negative. What is positive? Promotion. If it is not promotion, it is promoted no, is negative. Is promoted S is, right? So we are bothered about this. But unfortunately, our model is not working well because of that 3439. Of course, we can't make it 0, but we have to reduce it to a level, which logistic regression is not able to predict. Getting it right? So what the client wants is, the client wants a model that will predict whether an employee will be promoted or not, based on the data given. Now, the problem with this model is, the model is giving you false negatives. Who are eligible will be for promotion, whose performance is good for promotion, the model is predicting them not to, which is bad for the company, right? What will employees do? They'll resign and go off. Even if they're working hard, even they achieve the training score, they've performed well. If they are not getting promoted, what they will do? They will leave the organization and go, which is a dangerous scenario, which is logistic regression is saying. It is not able to identify correctly people who are going to get promoted, because as per data, this is 1, but the predicted is, this is your false negative, which is the problematic scenario. So what option we have? Our logistic regression is not working well. We have to go for next set of models like decision trees, random forest, neural networks. Advanced models might have to be used for this. We have to correct the minority class problem. Imbalanced data is there, no? That is a problem. So actually, if you are looking at the correction, I think we have done it. Vaccine prediction we have done now. Okay, HR analytics also we have done balancing. I don't know which thing we have done. Imbalance 23. Yeah. In decision tree, we are getting good predictions. 99%. It is overfitting. You're correct. So we will do that. Two options are there. Either we have to use advanced models or we have to correct the imbalance. Then only this model will work. Intercept is this. These are the coefficients. 64 rows are there. See, we get the coefficients for each of the variables. Intercept and coefficients are required for the equation, right? For the equations, we need the intercept and coefficients. So these are the intercept and coefficients which are used for prediction. So this intercept and coefficients are used for creating the equation. What is the equation? Like I discussed in the top, right? This equation will be created. So the predict function, we are using dot predict, right? So this predict function will use the intercept and coefficients to create an equation and use that equation for prediction. And what is predicted in logistic regression? Probability. one of the common interview questions. What is predicted in classification problems? Probability. What is predicted in regression problems? Value. Actual numeric value is predicted. Number, integer or a. Whereas in you get probability as prediction in classification problem. Okay. And the probability range is between 0 and, if you know the probability of y, how will you calculate probability of no? 1 minus probability of. That is what we are doing here, right? So we are using the logic that if you know probability of no, what is the probability of s? 1 minus 0.82, which will be 0.18. If you know one probability, the other is calculated by deducting from 1. So first it will calculate the probability of the majority class. What is the majority here? Zeros. What is minority? Ones. Right? 0 and 1. We are trying to predict. And using these coefficients. These coefficients are used. See, all the coefficients for different classes are there. And then the intercept is also. Using this, the calculation will be done. Now, to predict on the test data, one last thing and then we'll end the session for today. Logit test predict is equal to logit model HR test df. HR test df is equal to HR test df dot drop is underscore promoted, comma, axis is equal to 1. We added the dependent variable, right? Temporarily. That we are deleting. Now we are using the model. This is the model we built on trained data. This is the model we have built on trained data. And we are using the input as, I am exporting the predictions to a CSV file. Exporting the predictions to a CSV file. Here we are predicting using the test data. We got the predicted values, right? Zeros and ones predicted we'll get. That we are putting it into a CSV file. Now just let me use the hackathon folder. There is HR analytics. So see, this is the file we got. These are our predictions. We also have our sample submission file. See, this is our sample submission file. Right? Now from here, the first one is column header. This 0 is column header. Don't copy that. From row to B2, Control Shift down arrow, Control C, copy them. Go to here, under is promoted. Do not touch the first column. Do not touch the headers. Paste it. Control S, save it. Okay. Now, let me submit. Once you copy the values into a sample submission, you can go to solution checker, HR analytics, sample submission. Solution is logistic, no, and then add solution. See, my score is 0.38. The F1 score is 0.38. Now, if you want to see what is the leaderboard, F1 score of 0.54 is the current leaderboard. Our score is 0. So, if you look at your my submissions, I have got highest is I think 0.49 using gradient boosting. That's a very powerful algorithm. So, as of now, 0.38, which is very far from 0.54. Because our model has already failed, right? AOC is 0.63. It is not able to predict. So our test predictions are also bad. So our score is also bad, 0.38. So this is the process of submitting to the competition. First, predict on the test data, write it into a CSV file, go to the CSV file, copy the predictions into the sample submission file, and then you upload the solution file into the solution checker. You will know your, okay, you can check how accurately your model is. This is the way. We'll build on this data multiple models and see each model's performance. Okay. And how our score improves for each model. If I run decision tree, it will go beyond 0.40. I think 0.42 or 41 something you'll get. If you run random forest, it will go up to 0.47. If you do gradient boosting, it goes up to 0.49. If you do neural networks, it might go up to 0.46 or 47, something like that. So each model will improve your logistic regression is a basic model. It's a basic model. And it does not perform well when you have too many categorical variables. In this case, we have a lot of categorical variables, right? Because of get the maze, we have a lot of variables. Region, education, all those things. If you see from the coefficients, department operations, they're all 0, 1, 0, 1, right? If there are more numeric variables and less categorical variables, this would have better performed. But in our case, our numeric variables are very less, 8 or 9, that's all. But rest of the 51 variables are all binary variables, 0 and 1. Right, this one. See, like in the coefficients, you can see, right? See, awards 1, 0, awards 1, 1, KPIs met 0, KPIs met 1. These are all binary, no? 0 and 1. That's why the model performance is not. So this is the process of working on a competition data set or a real-time hackathon data set. You build model, first clean the data, pre-processing, cleaning and all. Because model building is very small part, right? Model building is the biggest problem is data cleaning. How to clean, how to impute missing values, how to get it proper shape and all. Then model building is simply X and Y and fitting, scoring and predicting. That's all. But bringing data to that structure is 95% of your time. And the model failure or success depends on your pre-processing, how you pre-process the. So we'll stop here and we'll continue in the Tuesday session. If you have time, you can work on the bank data set. You can build a logistic regression model. Anyway, I'll do it on Tuesday. We will do it again. And in Tuesday class, you'll also do the manual calculation of logistic regression using Microsoft Excel. Then you'll understand what is it, iterations and solvers and all. You'll get a clarity.